Hello everyone. Today we're going to be looking at a derivation of a formula that's not taught at high schools very much. This is the formula for determining the area of a triangle given three sides without any angle. This formula is called Heron's formula. So this is how the derivation comes. So let's say we have any triangle and we name this triangle A, B, and C. Then the distances or the lengths of the sides will be labeled with smaller case letters opposite to each angle. We have A opposite to angle A, and B opposite to angle B, and C opposite to angle C. Then from here we're going to use a formula for the area of a triangle. So we know that the area of a triangle is given by half BC sine A. Then we make sine A the subject of the formula. So we multiply both sides by 2 and then divide by BC. And from here we square this, giving us sine squared A equals to 4 times the square of the area divided by B squared, C squared. Then let's take this formula and put it on the side, clear up some space here, and then go on ahead and use the cosine rule on the same triangle. Cosine rule gives us A squared equals B squared plus C squared minus 2BC cos A. Then again here we're going to make cos A the subject of the formula. So we'll take the term with the cos A to the other side, take A to the right hand side, and then divide both sides by 2BC. Then again here we will square our result. Square both sides, we get cos squared A equals to B squared plus C squared minus A squared, quantity squared over 4B squared C squared. Then we use the square identities to change the cos squared A into 1 minus cos squared A. The right hand side remains as it was. Then next we bring the fraction to the left hand side and sine squared to the other side. Then now we add or subtract 1 from, we subtract from 1 the fraction that we have there. So we get 4B squared C squared minus B squared plus C squared minus A squared, quantity squared over 4B squared C squared equals to sine squared A. So let's bring this to the top, and we see that in the numerator now we have our fraction that looks like a difference of 2 squares. We will deal with that later. But now what we realize is that we have sine squared on the right hand side of this first equation and sine squared on the left hand side of that old equation that we put down. So it means the left hand side of this equation will be equals to the right hand side of this equation. So we take them, let's move the triangle away and equate them. Then and continue with this. So we have two terms in the numerator here. So this is a square and this is also a square. Then it means we can factorize them using the difference of 2 squares, and then we end up with this. Then with a little bit of rearrangement, if we multiply the negative into the bracket, we can end up with another arrangement of A squared minus B squared plus minus 2BC plus C squared. We're doing this because we know that this is a perfect square. This is also a perfect square. Then it can be factorized. Then what we did is now we multiplied both sides by b squared c squared so that we don't have this term anymore in the bottom. Then we divided both sides by 4 to get our 16 here. So factorizing these two, we get b minus c squared and b plus c squared for the second. Then if you look here, you see that again we have the difference of two squares in this bracket and a difference of two squares in here, which means we can factorize that further. The red part is going to give us the red part in the next step. So this part is given by, was obtained by factorizing this red, and this one was obtained by factorizing this one. Okay, now from here what we will do is we multiply the brackets in the first bracket, multiply it out, then we make a little manipulation, algebraic manipulation, then we try and make a plus b plus c in each of these fractions, this brackets. Let's take this and put it on the top and create some space. So now we go on to look for what we call the semi-perimeter of a triangle. This is adding all the sides of a triangle and dividing by 2. So that's half of the perimeter. That's why we call it the semi-perimeter. So as you can see here, we have tried to make a plus b plus c in here because of this relationship. So now we multiply both sides by 2 to get a plus b plus c equals 2s. And then we see that this a plus b plus c is in each of these brackets. And then we can substitute 2s instead of them. Then we end up with this. Now taking 2 as a common factor from this bracket and from this bracket and from this bracket, we get a 3 2's that give us 8 multiplied by the last 2 here, and then it gives us 16. And then we see that the 16 can cancel. We end up with a nice formula that looks like this. But here again, we still have a square here. So to get the area of the triangle ABC alone, we just square root both sides. And then we get a nice formula. Please like and subscribe for more videos. And we'll see you on the next one.